Okay, this week in AP Calc, we're going to do derivatives, second derivatives, Khan Academy review today.
Second derivative?
Yeah.
Are you turning off the light or leaving?
I prefer first derivatives.
Wait, is the test on Wednesday?
Then on Wednesday,
First derivatives.
you'll have time to do the Khan Academy test after we review for the AP Classroom test. And then on Friday will be the AP Classroom test over Chapter 3. Too bad this is AP Calc. We don't follow rules. You will have, there's only, I think, 13 questions. All right. So let's look at this. Do not work on your other schoolwork right now or earlier AP Calc problems, because if you miss this, then you'll just be lost. And so let's make sure we understand this. Second derivatives, this is how it works. Now, I'm giving you the easy example first, and then we'll get into the hard ones. But if the function is this, you just take the first derivative, which is this. Everybody sees that how we get the first derivative. Then we take the derivative of that derivative, and we get that. Second derivative, easy peasy lemon squeezy, right? Right, until we get to problems like this involving the chain rule, because then we have to take the derivative, and then it gets complicated, and then we take the derivative of that, which is even more complicated.
Can we just let me write down the section title?
Okay. So on this, we see that we have to do the chain rule. So it is 5 times the inside, negative 5x plus 6 to the 4th power times the first derivative of the inside, which is negative 5, which we need to rewrite it before we try to take another derivative. Rewriting it is just negative 25 times 5x plus 6 to the 4th power, negative 5x plus 6 to the 4th power. Okay, that's the first derivative. Chain rule. We can handle that. Now, take the second derivative. The second derivative of this is take 4 times negative 25, and it's negative 100 times negative 5x plus 6 to the 3rd power times negative 5, which gives us a positive 500 times negative 5x plus 6 to the 3rd power. Second derivative. Okay, so just take a derivative and a derivative again.
What does the second derivative find if the first derivative is?
It finds the concavity of the function.
That's a nice word.
Oh, okay.
What is concavity?
Concavity is, this is concave up, this is concave down.
So it's the third derivative.
No, we don't worry about the third derivative. But we can find third and fourth and fifth derivatives. All right. So what's the first derivative of e to the 7x plus 4? The first derivative of it. E to the 7x plus, no, 7x minus 4 times chain rule. Take the derivative of that. So it's 7. So the first derivative is 7, e to the 7x minus 4. So then what's the second derivative of this? Well, it's 7 e to the 7x minus 4 times 7. So it's 49 e to the 7x minus 4. Yeah, e to the x, the first derivative of e to the x is e to the x. So the first derivative of e to the 7x minus 4 is e to 7x minus 4 times the derivative of the power. Because the derivative of x is just 1. So it's 1 e to the x. So the first derivative of e to the x is 1 e to the x, which is still just e to the x. That doesn't change. So you just have to take the derivative of the power each time. All right, first derivative of this thing. What's the... Yeah, you can. Honestly, when you take the derivative of cosine, it is negative sine. So this is negative 5 sine of 2x plus 10 times the first derivative of the inside, which is 2. So the first derivative is negative 10 sine of 2x plus 10. Now, what's the second derivative of that? Negative 10 cosine 2x plus 10 times 2. Or negative 20 cosine of 2x plus 10. So this isn't too bad, is it? Okay, what's the first derivative of 3 to the x?
Three to the x.
3 to the x ln of 3. Yeah, same thing. Times the natural log of the base. Because it's in the formula, that's the a to the x power, where you have a number as the base. Okay?
Can we have it on the AP test?
Not the May AP test, no.
Can we make the exceptions?
No. What?
The Friday.
The Friday test, you can use your formula sheets, yes.
Oh, these are on our formula sheets?
Yeah, that's on your formula sheet. The only thing that hasn't been on your formula sheet so far is the inverse one. And didn't you write that on your formula sheet? Didn't I tell you to write it on there? Okay. The inverse of a function, yeah. So yes, you can use those on the test. Okay. So now what do we do when we find the second derivative?
Good question.
Good job, Henry. It's the product rule. So it's the first times the first derivative of the second. What's the first derivative of the natural log of 3?
No. 1 over. No. 3 over x. It's not the 1 over x thing?
1 over 3.
It is the 1 over x thing.
1 over 3. 1/3.
0.
It's, there you go.
Oh, it is 0.
Kate got it right. Or were you?
No,
Who said 0?
it is 0.
Kate did?
Why is it 0?
Because it's 1 over 3 times the first derivative of 3, which is 0.
How is it times the derivative?
No, I don't understand. I guess 0.
Since when would we do that?
I was
Oh,
laughing
because
at
it's
you
not
because I thought that was a dumb guess.
There is no variable there.
Oh,
So it's like a constant. The first derivative of the constant term is 0.
Wait, why do we
So
do 1 over
basically
3
it's 0?
times the first derivative of 3?
that makes sense. Okay.
The ln of x is 1 over x times the first derivative of x. Well, the first derivative of x is 1.
You would always just say ln of x equals
So the
1 over
ln of 2x is 1 over 2x times the first derivative of 2x, which is 2. Yes.
You would
Yes.
always just ln of x equals 1 over x. Never 1 1 over x times the first derivative. Right?
Well, all of these are because of the chain rule.
Yeah,
All
because it's
these.
just 1, but that's not implied to me.
Well, time to imply it now because of the chain rule.
That attitude is not there.
Plus the ln of 3 times, what's the first derivative of 3x? 3 to the x ln of 3.
I'm just going to teach this.
So this times this is what? What's 3 to the x times 1/3 times 0? 0. So that's just 0 plus 3 to the x, the ln of 3 squared. So it's just that. Okay. So that was second derivatives with a lot of chain rule involved. Okay? All right. We are given that dy dx equals that. What's the second derivative of that? This is the first derivative.
2x. And then
I don't know why they invented it that way. That's just.
squared y over dx squared.
So what's the second derivative of this? 2x minus 2 dy dx, right?
Yeah.
But we're not done.
We're not done.
No. Because this is 2x minus 2 times, since we know what dy dx is, we substitute that in. So it's 2x minus 2x squared plus 4y. That's the second derivative.
Wait. I thought you only did one derivative. Oh.
This, we were given the first derivative. So we only took one derivative there.
That is
Okay, so
I'm not going to be able to do this. Are you picking the essay? I'm supposed to.
okay, here's the circle formula. We want to find the, not the slope, but the concavity at 4, 3. So let's take the first derivative and then let's find the second derivative. What's the first derivative of this? Two x plus 2y dy dx equals 0. You guys are on the ball. But we got to get dy dx alone. So 2y dy dx equals negative 2x. And then divide by negative 2y. Because we want to get dy dx alone.
Isn't the 2y positive?
2y is positive. So it's negative y over x is the first derivative. So the slope at 4, 3 is negative 4/3. That's what the slope is there. Now we want to find the concavity. What's the concavity?
Quotient rule.
Quotient rule. Very good. I love it when people know what's going on.
Not this girl.
So it's y times the first derivative of the numerator, negative 1, minus x times the first derivative of the denominator.
dy dx.
There we go. All over the denominator squared. So it's negative y minus x times
dy dx.
negative x over y. That's what dy dx is. Over y y squared, which
Oh, I see
equals
what you did there, silly little fart.
negative y plus x squared over y squared. Yeah, I'm an old fart, that's for sure. Yeah, your dad's not that old.
He is. He's like 40 something.
He's 40 something, and I taught him.
So
Yeah.
that means you're 80 something.
Thanks, Kate.
Basically.
So 1 over what? Since I have a complex fraction, I'm going to multiply the whole numerator by the reciprocal of the denominator. So you get negative y over y squared plus x squared over y cubed. Well, I would simplify it to negative, well, you could multiply this by y over y to get negative y squared plus x squared. Sorry, that shouldn't be in there, over y cubed. And this is the answer, except
Then you have to plug your values.
plug the values in of 4, 3.
Could you just plug the values in?
You could have plugged it in way back here on this one. I forgot we were plugging in values. We wouldn't have had to go that far, but okay. Still, put in a 3, we get negative 9 plus 16 over 27. Right? So it is 7/27. It's concave up because it's positive. Yep.
So is it like this?
So what is,
So draw me a line.
what application does it have?
Yep. Now the slope of a certain point on that line, I get that. It's like slope at like there's that. Now what's the concave at that point?
Concavity.
Yeah. Okay.
So what's happening is because it's going like this at 4, 3. Ooh, I wonder why the concavity. I wonder if I made a sign error because the concavity I would think there would be negative 4, 3. Yeah, I don't know.
That's a regular 4-3.
Interesting.
Yeah.
Oh,
Well,
well.
again, applications of concavity there. There are not many applications of concavity there.
Are there? Like,
Concavity is, we'll get to it, but it's not as applications as slope is. Slope has all kinds of applications. Concavity doesn't have as much. There is application, and like I said, we'll get to it, but I can't think of anything off the top of my head right now.
What are you finding when you find like the third and the fourth and the fifth?
I don't know. It's slope and concavity are the first and second derivatives. Okay, so we're given that the first derivative is this. What's the second derivative? So we got to do the,
Product rule.
there we go, product rule.
Yes.
So it's 3x squared times the first derivative of y, which is dy dx, plus y times the first derivative of 3x squared, which is?
6x.
And then, since dy dx we know, we plug it in.
What was the question again? Sorry.
Since we already know dy dx, we plug it in, and then we simplify. 9x to the fourth y plus 6xy. That's the second derivative. Now disguise derivatives. So now we got to think backwards a little bit. What is this? Well, if we know the difference quotient is this, what would f of x be? using an x, not numbers. Since we know the difference quotient, what would f of x be? 6 arctangent of x. Okay? So we're finding the first derivative of 6 arctangent of x at 1. Now, how can we do that? Well, we could use our graphing calculator if you wanted. Or you could graph 6 arctangent of x, or 6, you could go y equals 6 inverse tangent of x, graph it, and see what the slope is at 1. Or we can use the arctangent formula, which is 6 times 1 over 1 plus x squared. Well, what is x in this case? 1 squared. So it's 6 over 1 plus 1 squared is 1 plus 1, which is 2. So 6 over 2, which is 3. Why are we doing this? To just kind of go over what we've learned and apply it to working backwards with this stuff. So we know how to work backwards with the difference quotient. Yep. So what would the function be for this one? 2 cube root of x. Nope, don't have to look at the h's. The 8 comes from, that's where we're finding the derivative at. So what is the first derivative of this at 8?
Does it ask for that in the question?
No, it says find this. So what we're doing is, what do we do to get there? So we have to take this and take the first derivative of it at 8. So this is 2x to the 1/3 power. What's the first derivative of that? 2/3 x to the negative 2/3, or 2 over 3 times the cube root of x squared. Because x to the negative 2/3 is x to the 2/3 on the bottom. X to the 2/3 on the bottom is the cube root of x squared. What is the number I'm taking the cube root of? 8. So it's 2 times 3 times the cube root of 8, and then we're squaring it. I would rather do it in that order than take the cube root of 64. Either way, cube root of 8 is 2. 2 squared is 4. So 2/12 is the same as 1/6. Find the first derivative, plug an x in there, find the first derivative of that, and then plug the number that it is in the problem. You just have to find what you're taking the derivative of and then go from there. Don't worry about the h's or anything like that. Okay? So that's the first set of problems, and then you'll have your Khan Academy test. So I'm going to review for the Khan Academy test right now so we don't have to take a break later. Well, I'm going to review right now, so that's your choice. All right, Khan Academy review. So, and this is just a general review of the chapter, just to kind of wrap your minds around this one more time. So, what's first derivative of this? First derivative of sine is cosine. So we take the cosine of 2x minus pi over 3 times the first derivative of the inside. What's the first derivative of the inside? Just 2, because pi over 3 is a constant function term. So it's 2 cosine of, it says at pi, So it'll be 2 pi minus pi over 3. What's 2 pi minus pi over 3? 6 pi over 3 minus 2 pi over 3. 6 pi over 3 over pi over 3 is 5 pi over 3. What's the cosine of 5 pi over 3? Well, you look at your unit circle and you see that that is positive 1/2. 2 times 1/2 is 1. What does this look like? Chain rule. So it is 3 cosine cubed of x to the 1/2 power, which is 1/2 of 3 cosine cubed of x to the negative 1/2 times the first derivative of the inside. First derivative of the inside is 9
Oh, yeah.
cosine squared of x times, it's a chain, times, okay, times the first derivative of the inside, which is negative sine of x. Okay.
The inside is sine and the
Let's
outside
start again. So it's 1/2 times 3 cosine cubed of x to the negative 1/2. Now we're going to rewrite this as 1/2 times 3 times cosine of x cubed to the negative 1/2. Okay, then we have to take the first derivative of the inside. Well, the inside would be this part. What's the first derivative of that? 9 cosine of x squared times the first derivative of the inside of this, which would be negative sine of x. So in the numerator, we'd have a negative 9 cosine squared of x sine of x. In my denominator, I'd have a 2 and a square root of 3 cosine cubed of x. Which is choice B. This is all in the numerator because this is to a negative exponent. It goes to the denominator inside a square root because it's all to the negative 1/2 power.
and the 2 on the bottom.
Is from the 1/2. Take the second derivative of this. Well, before I start this, the first derivative I want to find is from our first function is 6x to the negative second. So our first derivative of this would be negative 12x to the negative third power. Then our second derivative would be 36x to the negative fourth, which is 36 over x to the fourth. That's the same question. I got on there twice. All right. Inverse functions? Yes. Well, it's the chain rule. Actually, this is a chain rule. They're not inverse functions, are they? So chain rule. So it's the first derivative of the first derivative of f at h of x times the first derivative of h of x. Well, what is h of x? It's h of 2. So it's the first derivative of h of 2. h of 2 is negative 1. So it's the first derivative of f at negative 1. First derivative of f at negative 1 is negative 5 times the first derivative of h of x at 2, which is 6, which gives us negative 30. Chain rule. The first derivative of arctan of 2x at negative 2. Well, formula for arctangent is 1 over 1 plus x squared times the derivative of x. So it's 1 over 1 plus 2x squared times the first derivative of 2x, which is 2. So it's going to be 2 over 1 plus 4x squared. Now we're putting a negative 2 in for x squared. So it's 2 over 1 plus 16, or it's 2/17. Inverse functions. G prime of 2. So it's 1 over f prime of g of negative 2. What's g of negative 2? Well, it's 5. So it's 1 over f prime of 5. What's f prime of 5? Well, it's negative 1/2. So the final answer is negative 2. Little disguised derivatives here. Well, no, it's not disguised derivatives. It is, what is our function here? It's actually 7x to the 7e to the x, where x equals 4. Okay? So what's the first derivative of 7e to the x? 7e to the x, where x is 4, so it's 7e to the 4th. So that was that disguised derivative thing. Okay, second derivative of this. Well, what's the first derivative of this? Three x squared plus 2y dy dx equals 0. So dy dx equals negative 3x squared divided by 2y. Because we have to subtract 3x squared and divide by 2y on each side. So then, the first derivative of x equals 3x squared plus, and then if we plug this in, dx dy, wait, no. Okay. What am I doing? All right. Yeah. So now it's quotient rule. So it's 2y times the first derivative of the top, which is negative 6x, minus negative 3x squared times first derivative of the bottom, which is 2 dy dx over 2y squared. Now at this point, it might be easier just to plug in the numbers. So 2 times 4 times -6 times 2 minus, and if it's minus a negative, if we go plus a positive right here, that might help us. So plus 3x squared is 2 squared times 2 dy dx. If we plug the numbers into dy dx, we get 4 times 3, which is -12, over 2 times 4, which is 8, which if we reduce it by 4 is -3/2, over 2y squared. So 8, 16, 96, so it's -96, plus -9 times 4 is 36, over 32, -60 over 32, which is -15 over 8. Inner and outer functions. Square root of x is the inner and outer is log of x. That's easy. You guys know how to do that. What rule will we use here? Quotient and chain. Implicit differentiation. First derivative is 2x times first derivative of y, which is 2y dx, plus y times first derivative of 2x, which is 2, plus 3x squared minus 6y dy dx equals 0. So move everything that's not a dy dx to the other side. So it's 2x minus 6y dy dx equals -2y minus 3x squared. Divide by 2x plus minus 6y. So, what is it? Well, if we factor out a -1, it would be a. Jacob tried this. Here's his work. He said, let's do the product rule. So the product rule is this times this. It's not that. That is not the product rule. Product rule has a plus sign in it. How can we differentiate this using the power rule? Well, if we distribute, then we can do the power rule. What's the first derivative of that? Well, it's 7, because it's the sign. Really, this is the sine of x to the 7th power. So it's 7 sine of x to the 6th power times the first derivative of the inside, which is cosine of x, which is that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. About 17 problems on the Khan Academy test. I think there's about 13 on your other test. So I will go back to my desk and put this stuff out.